Myself, Mr. Zambare, Colonel Prof. Patil Mahendale Pandharpur, Department of Chemistry. Today, we are to start our third experiment of physical chemistry, that is conductometric titration. Aim of the experiment: titration of mixture of weak acid and strong acid with strong alkali. Those experiments which are carried out in case of two parts. Out of them, first is calibration of conductivity bridge or conductometer, and second part actually titration of the mixture of weak acid and strong acid with strong alkali. First of all, we have to here switch on our conductometer, and those we have to arrange some reading on conductometer. That's like here 0.006. Just also see about this reading, and those having a 4 digits 1, 2, 3 and 4, but the solutions we have to given, those reading will be given in case of that mixture. Here first we have to calibrate about given instrument. Here one arrow is given to you and here screw. By this adjustment we have to adjust this reading up to here 1.000. Then those instrument is a caliber to perform the further experiments. Just we have to start our calibrations just like here now as this mode here. See, the change may appear about this particular digits. Say here the reading will be appear 1.001, but this is not the standard reading. We have to use this screw and adjust and to obtain the reading as like here. See, increasing order we have to reduce just and come the reading as like here 1.000 here, isn't it? Then we have to remove this knob in upward directions here. Then those conductometer bridge conductometer is useful to perform the further experiments. In second part of this experiment is the titration between mixture of weak acid, strong acid with alkali. Those requirement is given to you here. This is mixture of acids. Then second one is here the strong alkali. The strong alkali having the normality is a 0.2 normal. Then another requirement, that's like here distilled water. Then another here one 10 ml pipette and second one here one of the burette, isn't it? We have to start actually our titrations as like here. First of all, we have to withdraw 10 ml of a given acid mixture by means of your pipette and transfer it in our beaker, that is a 100 ml beaker here. Just as so, suck or pipette out about this mixture. Just we have to adjust this given mixture up to the mark of the pipette as like here. Okay. Then those total 10 ml mixture we have to fill in a beaker here. Okay. Then we have to dilute the given mixture of acids up to 60 ml, means 50 ml of distilled water can be added in beaker. And like here, already the beaker have mark. The total volume 10 plus 50, that is here 60. Okay, 60. Kept on the table here. Then we have to supply here one conductivity cell, and those are connected to the given device, that is instrument conductometer. Then we have to dip those conductivity cell in the mixture of acid. Those are already diluted. At the purpose of this cell is one of here. The solution whose concentration or conductance is to be determined is one of the particular cell. We have to call about that is a cell, means conductivity cell. Those are dipped in the mixture. Those are diluted already, and we have to record our reading without addition of alkali here. And the first reading may be appear here. Just we have to image read here those reading as well here. Okay. The reading may be appear here 6.14. But here those reading may be like here 6.13. Here MS, M indicate milli, and S indicate Simon. About this M, like the value 10 raised to minus 3, and we have to read every time those reading 6.12 into 10 raised to minus 3 Simon. This is without addition of strong alkali. Then after reading we have to add here the strong alkali by means of this burette. We have to fill this burette by means of your strong alkali here. Just we have to fill those burette by means of strong alkali. Here about this, how the filling may appear. Completely, because to remove here air bubble from the burette. Okay, then we have to remove the air bubble as like this. Okay, then we have to adjust the initial level as a 0 here. Share about this 0 level may appear here. Then after observing the conductance of first reading without addition of here strong alkali, then we have to add from burette 0.5 ml in the beaker, just like here 0.5 ml. Okay, then we have to just stir. Just means we have to stop. Then we have to record the second reading, which addition here 0.5 ml addition. Then again we have to add 0.5 ml. Okay. Then we have to stir again. Record third reading. The reading at first high. After addition of alkali, those reading will be decreased. Decreasing. Then we have to add up to here the total amount of strong alkali, that is a 12 ml or it may be a 15 ml. Means how many reading will be obtained here? If we have to add the 15 ml of strong alkali in the beaker, total reading will be appear, that is a 31. how it is here? 0.5 every time addition, that is the total reading is 30, and first reading is without addition of strong alkali, that is first, means total reading 31. Yes, okay. Again we have to add here 0.5, then sterility, reading will be decreased. Again we have to add here 0.5. In the same manner, we have to obtain every addition of alkali, strong alkali, the reading will be reduced. After one declaration point will appear, and after addition of this strong alkali, those reading will be again increases. The nature of graph will be obtained. See, just we have to stop about this here titrations. Which one here? Actually, we have to addition every time 0.5 ml, 0.5 ml, 0.5 ml up to here 15 ml completion of this strong alkali. Then we have to stop here. The observation will see, observations means here reading observed conductance, like here high, then decreases, isn't it? Then it can be just increases, again second equivalence point will appear, then again there will be increases, and after completion of this titration, both the equivalence point will be appear, one from strong acid, other from weak acid here, by the addition of strong alkali. The experiment may be conducted about here the complete titrations. Then we have to stop about this reading, and we have to represent about our observations. Our observations in the tabular forms, like here serial number 1, 2 and songs, then ml of alkali added, like here 0.00 ml, and observed conductance into 10 raised to minus 3. About those reading we have to represent it. The total tabular form will be obtained. After completion of our tabular form of this observation table, then we have to represent here our nature of graph, then secondly calculations, and last that is the result of this experiment. I want that here to stop. Tomorrow we have to discuss the remaining part of our calculation, nature of graph, and last that is results. Okay? Okay.